Hey guys, this is Srini and you're watching basic Python tutorials on my channel Python for Microscopists on YouTube. And these tutorials again are intended for beginner programmers who are students, researchers, or any image processing enthusiasts who's interested in automating image processing tasks using Python. Now, in today's tutorial, we're going to talk about basic image processing tasks, a couple of them, using Scipy, which is, again, a library in Python that is part of numpy stack. We talked about numpy arrays in the in one of our previous videos, and Scipy is part of this numpy stack. Now, it contains modules for linear algebra, FFT, like for fast Fourier transform, for example, if you want to do some signal processing, and also image processing, because that is almost like a subset of image signal processing. But Scipy is definitely not designed specifically for image processing tasks. So let's cover a few basics and quickly move on to our next topic in the next video, where we cover libraries that are actually designed for image processing. So let's jump onto our IDE, and again I'm using Spider, which is part of Anaconda distribution, and Scipy should be already part of this if you install the entire Anaconda package. So like in any other libraries that we use for Python that deals with data, Scipy also has a way of importing data. And since it's built on top of NumPy, it would be no surprise that the image that you read using Scipy is a NumPy array. And we'll check that in a second. So the way you do this is from Scipy import MISC. The fact that importing images is part of miscellaneous in Scipy makes me a bit uncomfortable. That's why I try to use something else, just for no other reason, just because of this. So let's say my image variable, this is equals to miscellaneous dot, and like in most languages, most packages, it is imread. And let's actually open our monkey image, because when we do some processing, it's easy for us to see the physical thing, flip or rotate or do something. So let's go ahead and read our monkey, image. And again, this is part of my images slash, and I have monkey, hopefully, yeah, it's right there. So first of all, let's go ahead and print the type of this image. So it should come back and say it's an ND array. So it did come back and saying that this is a NumPy array, but it actually throws some warning here saying that imread is, I keep saying this as imread, and some people say it imread, it's up to you. Imread is depreciated in Scipy 1.0.0 and will be removed in 1.2.0. Whatever that means, let's not get into that. That warning again also makes me a bit uncomfortable using this way of reading images. So I tend to fall back to my comfort zone, which is either OpenCV or Matplotlib or skimage. Skimage is probably one of the best ones. From skimage, I'm going to import IO and pretty much do the same thing. Image equals to how do we do io.imread. Okay, images slash monkey.jpg, and let's print the type again. Images, just to confirm that this is also a NumPy array class. It's a NumPy array, so it doesn't matter what you use. You can use either to open your images. So let me go ahead and clean this up. Let me not use the Scipy, although this whole lecture tutorial is about Scipy. I just want to import the image in a different way. Okay, so now we have our image. Let's see what do we want to do once we have our image. We already looked at this is a NumPy array, and there are things that you can do like image.shape that tells you what is the shape, what is the data type of our image here. So again, just quickly print img.dtype data type, when I run this, it's a unsigned integer 8. Okay, now I can actually, let's go ahead and do this. Let's also print shape. This is 330 by 220 by 3, and it's a unsigned integer 8. This means this is a RGB image, red, green, and blue. And in fact, when I import this, I can actually say as gray equals true, and when I click here, now it says 330, 220. The third dimension is gone because this is a gray level image, and it's converted into float 64. Okay, all values I believe are between 0 and 1, so we can go ahead and print image right now. In fact, if I go to variable explorer, it should say right there float 64, and I don't even need to print my image. All the values are between 0 and 1. Now if you want this to be again back to 8-bit, we know how to do that from sk image. I think we also have image as you byte, and I can just type that here, image as you byte. This should convert this image back to let's not print the image. This should convert the image back to unsigned integer 8. So anyway, by reading the image, it was in RGB. I converted that into gray, and then we realized that it changed the image back to float, and now I'm converting it back to 8. Again, just quickly going through a few of the things that we have already tested in the past. So since this is a numpy array, again, we can actually extract individual pixel values. For example, if I say print image and pixel value of 0 and 0 and 0. Yeah, so what is the pixel value of 0, 0? And you would see that it is 63. Just single value because we converted this into a gray. Now if I just go back and just say false here, it would be RGB image, and we should be able to see 3 different values, 61, 66, and 46 for 0, 0 pixel. Okay, so and if you want to get a range of these values, let's go back and say, okay, this is true. And if you want to get range of these values, then we know how to do this, right? I mean, then all we need to do is just do 0, for example. Let's just do 10, 15 to, let's say, 20, 25. And let's go ahead and print this, and hopefully this should print a matrix of numbers between these pixels of all the pixel values right there. So this is how you can actually create a subset. You can create like almost like cropping your image, because you're actually getting a sub, you're slicing your data set. And a few other things. Let's say if you want to find out the mean gray level, then mean, let's call this mean underscore gray. This is nothing but image.mean, and I could have just directly printed this, but let's actually do maximum value equals image.max. Again, these are the things that we've already tried before. And let's try minimum, and this would be image.minimum img, and we can go ahead and print. Let's just print the values. I mean, you can actually properly format it by saying, okay, let's go ahead and say min, max, and mean r. And we can even format it in a much better way, but let's just go ahead and do min underscore value, max underscore value, and mean underscore, I should have just said value, but this is fine. So let's go ahead and print this, and you can see that it's saying only integer scale bar. So again, there is something that we did here, min, max, and mean or minimum value, and as gray equals to true. So is for some reason this is only integer scalar can be converted to a scalar index. Arrival access. So again, must have done very simple mistake here. Yeah, I know exactly what I've done here. this should not be here. We've already mentioned image dot mean, right? There is no argument going in there. Again, these are the mistakes that if you watched all of my tutorials, you can see that I make this almost on a daily basis. I never seem to learn here, but then I don't do this on every day on a regular basis. But if you do this, this would be like your second nature. So let's go ahead and print this out, and hopefully we should see some values now. Min, max, and mean are 3, 255, and 133.444 something. Okay, so these are the minimum maximum. Now let's actually look at some image processing. Well, basic geometric transformation, for example. Let's flip this image, and again, just like in Pillow, here you can flip the image from left to right or up to down, and there are pre-built functions in numpy actually, and we are not importing numpy. So let me go ahead and delete all of this and keep the code clean. And let's import from numpy, import nd image. Okay, so let's go ahead and import nd image from numpy, and this is from Scipy, sorry about that. From Scipy, import nd image, and nd image actually has, again, you can look at the documentation, it has a lot of built-in functions, and I'm going to just go through a few of these, and I'm going to give you a link where you can actually get even more information about this. So let's just do flipped LR left to right equals to, now this is NP. Let's go ahead and I'm not going to use nd image yet. Let's also import numpy as np. I knew there was a reason why I was typing np and I got distracted, got into nd image. Let's not get into nd image yet. Np dot. Now if you go through the list here, you can see a whole bunch, and one of these is flip LR left to right. Okay, and what do we want to flip? This image, and pretty much the same thing. Let's say flipped up and down equal to, and what is this saying here? Invalid syntax, and flipped so I hate that sometimes this thing lingers long after I'm done typing that line, which wastes some of our time. But anyway, let's get back, and np dot flip up down, and again this is our image. So this is it. So you can flip images left and right, you can flip images up and down, and let's go ahead and show this. Now since I have two images that I want to show, I don't think I covered this in any of my previous tutorials. In fact, a couple of times I tried to print two of these, but I didn't want to get into explaining that. But since this is hopefully a relatively short video, let me go ahead and include this. So if you want to plot multiple, first of all, for plotting, do not think much. From matplotlib import pyplot as plt. This is something you should memorize, like I mentioned in my previous videos. So within plot plt, you can do something called subplot, and you can define how many columns, how many rows, how many images you want. Again, please go ahead and look at documentation for subplot. Now, once I define the position, what do I want to do? Plot im show, and I want to plot image. Okay, and I want to, let's go ahead and do this. And then the next image, I want to plot this at subplot, and I want to do this at 223. Okay, and I want to plot im show, and I want to show the flipped LR image. And let's do one more, flipped up down image. So plt dot subplot, and then let's do 2 2 4. I think they should put this, sometimes I just experiment and see, dot im show flipped up and down. So all of that just to show these three images in a nice and formatted way. So when I run this, you should see the original image on the top, the flipped. I mean, these are gray level images. If I actually change this to false, you should see original image, which is easier for us to see. This is the original image on the top, and this one is looking the other way around, and this is the flipped image. So you can see how you can actually do some basic image processing. And by the way, let me go back to true. One more thing I want to cover here. Let's go back to true and look at these color maps. In PyPlot, you can actually select your own color maps. I mean, if you want to plot this in gray level, or if you want to plot this in, for example, let's use image and let's call CMap equals to it's GREYS, grays. So this actually maps this in a gray scale. So as you can see, it converted that into grays. And let's call this CMap equals to, one other thing I remember is blues. And let's also change this one to CMap equal, let's just do HSV. And let's go ahead and plot these. CMap equals to HSV, and hopefully we should see that. So you can see, and there are a whole bunch of these. In fact, let me give you a URL here that let me actually open it on my other screen. I'm going to bring it here in a second. Oh, sorry. There it is. Matplotlib color maps. You can actually see when you go down all the way. Depending on the type of data set, you can actually pick the right type of color scheme. In fact, I would say this is absolutely an art, especially if you have a segmented image and if you want to highlight certain features, compared to the others. Picking the right colors map is can be very, very useful. So let me go ahead and minimize that, and I think we took a quick detour into understanding a little bit about the PyPlot. But let's go ahead and move on. Let me delete all of this again and keep the original image as is. Let's just do some rotation. So rotated equals, again, it's, let me use ND image. As part of ND image, there is something called rotate. As you can see, when I hit the dot, you can see the prompt over there. And now what do I want to rotate? I want to rotate my image, and by how much? Just type the value over there. Okay, and let's go ahead and do IM show, just single image rotated. And when you run this, you should be, and there it is, the image is rotated. Now again, if you don't want this to fit inside this box, just like in Pillow, we went through pretty much the same type of exercise. Here it is actually called here it is called reshape equals true or false. So by default it's true. Let's actually make it false, and you should see the difference right away. Okay, so it's not reshaped. Okay, so this is basic rotation operations, and now let's look at some filtering, image filtering. Thinking about what type of filters we have, there are a couple of filters that I at least know. One is uniform filter, and the other one is Gaussian filter, and there are other things that you can do like median and Sobel. Also, although I should mention, most of these filters are also available in Scikit image, which is completely designed for image processing. But since we're here, let's go ahead and experiment with a couple of these filters. So uniform filtered, this is let's part of ND image, and yeah, uniform filter right there. And let's just say image, and you need to provide like size. For example, let's call this size equals to 3, just like it's suggesting over here. Let's go ahead and plt.imshow uniform filtered, and go ahead and plot this. Not sure if you can see a lot of these, and if I actually change this to 9 and then go ahead and do this, uniform filter is again a type of blurring filter, as you can see. And another type of blurring filter is Gaussian filter, uh, which smooths the noise. In fact, Gaussian filter is an excellent choice if you want to smooth the noise in general, but you got to be careful, because if you apply it in a heavily, then the edges are gone. It doesn't preserve edges. So Gaussian filtered, let's override this. Gaussian filtered equals nd image dot nd image dot Gaussian filter. Okay, and again pretty much the same. Let's just call our image and sigma. Sigma is the amount of, think of this as the amount of Gaussian filtering that you would like to do, and Gaussian filtered. So let's go ahead and run this. You should see, okay, so with sigma 3 it looks like this. Let's actually go to sigma 7. So you can see how the blurring gets pretty heavy right there. Sigma 11 should be even more blurred. Again, this is nothing but just our Gaussian filtering, and typically these denoising algorithms like Gaussian and all of these, the way they actually work is, let's say you have a 3x3 patch, and it actually, one way of doing that is it averages out the values within the 3x3 and replaces all the pixels with the same type of value. That's what the easiest way of doing smoothing. And Gaussian, of course, it uses a Gaussian matrix, and it's not just a uniform matrix. And again, you can read about Gaussian filtering and any of the filters I show, in depth online. And we mentioned that Gaussian filtering actually is also blurring the edges. It's not preserving the edges. Median is a better one that actually preserves edges. So let's just do nd image. When I do dot, you can see there's a whole bunch of these here. You can do binary closing, dilation, erosion, fill holes. All of these operations, especially if you are coming from image J, let's say, you probably are familiar with most of these functions anyway. So for now, let's just do median filter, median underscore filter. And again, the arguments is image, and let's just do image for our median filter. And let's also do 3 over there, and let's do median filtered image. So now you can actually see that, again, it would be nice if you can experiment this with a noisy image. In fact, I do have a noisy image. I believe if we go to File Explorer, you can see Nucleo. Let's go ahead and try that. Nuclei tubulin. Small. Noisy. Dot and let's say as gray equals to false, and let's go ahead and run this. Median filtered, and here is a median filtered image, and the original image, it's tough to see with this screen size, and the original image again, you can try this on your own images. We looked at median filter. What else do we have? I would just let me go ahead and just do one other filter, or in fact, it's an edge detection algorithm. It's called Sobel, and here you can define the direction, the axis along X or along Y, along which axis do you want to define the Sobel filter here. So to run that, let's just do image equals to, again, this is part of nd image. That's the reason I imported nd image over there, and you can see Sobel filter, Sobel right there, nd image.sobel. And let's work with image again here, and we need to mention axis. If you don't mention axis, by default the axis equals to -1. Okay, so let's actually use default first, and then look at how it looks like when we change it. Image, and now let's just do plt.imshow Sobel image, and let's not do this. And when we run this, so it looks pretty noisy. Does it help if I change this to true? Maybe this is the wrong image or wrong axis. You see, I start to see something there. let's actually type a axis equals to 0 and then run this again and see if it makes any difference. And for this example, it didn't make anything. Let's see if it works for what other images do I have. Let's go back and let's look at 1.jpg in airplane. I think airplane is aligned in one direction. So at least even if there is a trend in a horizontal or somewhere in between, we should be able to see that. So let's do this one exercise. Images, test images, airplane slash 1.jpg. Okay, as gray equals to true. And let's not do our median filtering, just do Sobel, and let's go ahead and do this with axis. And you can see the airplane, in this case. Okay, if you have like a horizontal or vertical lines, this can be also very easy to see, the effect of that. Now again, if you want more filters, then you should be able to find them. If you again, the first one again, you can go to matplotlib.org and then look at colors and color maps. Okay, so for this one, I'm gonna just type Scipy, and then if you search for just ND image filters, for example, you'll probably find this page, and you can see how many filters you have. There are a whole bunch of these filters. There are Fourier filters, there are interpolation, measurements, morphology. I mean, I can show, it takes forever to show pretty much everything, but it's pretty straightforward and easy. My job here is to tell you that something like this exists, and I showed a couple of examples, and hopefully it gives you enough information to go get started with Scipy. So in our next lecture, let's actually cover scikit image, which is designed more for image processing. So, and I hope you found this tutorial helpful. And again, please don't forget to subscribe to this channel. It definitely helps us. So thank you very much.